74C number 37. For all real numbers such that x, for all real numbers x such that x does not equal 0, 4/5 plus 7 over x equals what? Now the reason x cannot be 0 is because we have this fraction 7 over x. And you cannot have division by 0. When you divide something by 0, can't be done. It doesn't exist. So that's why x does not equal 0. If a question ever asks you what makes a expression or equation not true or doesn't exist, how can we find when this equation doesn't exist? Whatever's in the denominator, just set it equal to 0. What if it was 7 over x squared plus 1? Well, set x squared plus 1 equal to 0. We won't actually solve it right now, but you would solve it and then find out what would make the denominator equal to 0. Well, let's solve it. X squared equals minus 1. This has nothing to do with question 37, but I'm just showing you if you had this expression and they would say which of the following which value of x makes this expression undefined, you'd set it equal to 0. X squared plus 1 equals 0. X squared equals negative 1. Take the square root of both sides. X equals plus or minus the square root of negative 1. Well, the square root of negative 1 is I. We have this, it's called the imaginary number. So x equals plus or minus I. That would be the answer to that question. If it asks, what value of x would make this expression doesn't exist, would make it invalid, would make it not exist. But anyway, you cannot divide by 0. So let me delete all of that stuff. And so that's why it says x is not equal 0, because in this case, if x equals 0, we'd have division by 0. All right, two ways to do this. We could either deal with the fractions and find a common denominator, or we could plug in some numbers. So I would say 4/5 plus 7x. What is the common denominator? Well, I cannot find a factor that goes into both x and 5, so I just have to make the denominator 5x. I just multiply them together. And you can do that anyway. Anytime you add fractions, you don't have to find the least common denominator. You can just find a common denominator by multiplying all the denominators together. Now, sometimes if you don't find the least common denominator, you will have to then do some simplification in the final answer. But it will get you to an answer. And by the way, to find the least common denominator, you can find the least common multiple on your calculator on the TI-84 family. It's math, num, and then you go down, I think it's number 8, and it's called least common multiple. That's the least common denominator. But anyway, in this case, we can't find a least common denominator, or the least common denominator is just 5 times x, or 5x. So let's convert these fractions both into something divided by 5x. And by the way, if I look at the answer choices, I can see that only b and e are divided by 5x. So, I'm sorry, a is also. So I could probably eliminate c and d just by finding that least common denominator in this case. So 5 goes into 5x, x times. 4 times x is 4x. X goes into 5x 5 times, because 5 times x is 5x. 5 times 7 is 35. So we have 4x plus 35, 4x plus 35 divided by 5x. That's one way to find the answer, and the answer is letter E. Now here's another way to find the answer. I'm going to plug in some number for x, and then I'm going to find what the value is in the original expression, and then compare it to what the value would be in the answer choices. Now, if you plug in your own number, you have to check it against every answer choice, because sometimes the number you plug in will work with more than one answer choice. Then you pick another number and you look at the answer choices that the first one worked with, and you see which one the second number works with, and you keep doing that until you have eliminated all but one answer choice. I don't think we'll have to do that here, but who knows? I'm going to say, to make this easy, I'm going to say x equal 5, because that way I'll have a common denominator already. So I have 4/5 plus 7/5 equals 12/5. So now I want to plug x equal 5 into my choices and see which one comes out to 12/5. Again, maybe more than one does, but hopefully only one will. So let me try A. I'm going to just write them over here. We have 11 over 5 times 5, which is 25. 11/25 does not equal 12/5. So A is out. A I have now eliminated. I've eliminated forever. So now even if more than one works with x equal 5, I never have to check another one with A. B is going to be 28 over 5 times 5, which is 25. 28/25 is not the same as 12/5. There's nothing I can divide those by to simplify, so it's not the same. 28/25 is a little bit more than 1. 12/5, if you would to do it on your calculator, it's a little bit more than 2, so it's way off. All right, C, I would have 11 over 5 plus 5, which is 10, 11/10. 11/10 does not equal 12/5. I forgot to cross out B. C is out. Let me try D. I'm putting in 5 for x. 7 times 5 is 35 plus 20 divided by 10. So that's 55 divided by 10. Now, I can divide both top and bottom by 5. 55 divided by 5 is 11. 10 divided by 5 is 2. That's 11/2. 11/2 does not equal 12/5. You can just put in your calculator 55/10 and see what number it comes out to, what number in decimal. And you'd see it doesn't come out to the same number in decimal as 12/5. All right, so now we're left with E, and we're plugging in 5 for x. 4 times 5 plus 35 divided by 5 times 5. So this is 20 plus 35, which is 55, divided by 25. And wait a minute. Wait just a minute. My original one, and I've made a mistake. I did this purposely to show you what happens when we make a mistake. 4/5 plus 7/5 is not 12/5. 7 plus 4 is 11. So this should be 11/5. It's not a disaster if you make a mistake, provided that you recover. So again, the first one, A, we came out to 11/25. That is not 11/5. B, we came out to 28/25, not 11/5. C is 11/2, not 11/5. C is 11/10, which is not 11/5. D is 11/2, which is not 11/5. And E, we can divide top and bottom by 5. 55 divided by 5 is 11. 25 divided by 5 is 5. 11/5. So E was the only one that worked when I plugged in x equal 5. And I even showed you what to do, if I made a little mistake when I evaluated the original expression by plugging in 5. I showed you we can always catch it even if we make a mistake. Okay, actually I made a mistake and I just caught it. And so I just kept going on with the video because I was too lazy to start it again from the beginning. But there you can see what happens if we plug in some number for x. Yeah, you might want to plug in just 1 for x. Let's just try 1 just to show you what would happen if we plugged in 1 for x. That might even be easier. A would be 11 times 5, the original expression, forgot to do that part, 4/5 plus 7 over 1. Well, in order to add fractions, we need a common denominator. 4/5 plus something over 5. 1 goes into 5 times. 5 times 7 is 35. That makes 39/5. So we want an answer choice that's equal to 39/5. If I plug in 1 for A, 11 over 5, that is not equal to 39/5. So A would be eliminated. B, if I plug in 1 for X, 28 over 5. That is not equal to 39 over 5. B is eliminated. C, I have 11 over 5 plus 1, 11/6. 11/6 is not 39/5. Out. D, 7 times 1 is 7 plus 20 is 27 divided by 6. That does not equal 39/5. D would be out. And E, 4 times 1 is 4 plus 35 is 39. It's looking good. And then 5 times 1 is 5, 39/5. So there, we just tried a different number. I plugged in 1. Maybe that would have been easier. And that came out to where, again, only E matched what I got for the original expression. I could not plug in x equals 0 because the question originally said x is not equal to 0. So I do not want to plug it in. You have to follow. When you create a number on your own, follow the instructions and then check it, whatever it equals in the original expression or equation, and then compare that to what happens when you plug that number into each answer choice. And you keep coming up with numbers until you've eliminated all but one answer choice. And whether we did x equal 5 here or x equal 1, both times we eliminated all answer choices except E. When you're working the test, once you did x equal 5 and found E was the only one remaining, you wouldn't then do x equal 1 also. I just did it as a matter of example to show you, hey, what happens if I plugged in a different number? Maybe you didn't think of 5. It still works. I really doubt there would be any number you'd find where more than one answer choice matched the original expression with this one. But there could be. Maybe a genius can figure it out right off the bat, but I can't. But if that happens, and let's say you eliminated B, C, and D, and only A and E were left with whatever the first number you came up with was, well, then you'd find another number and plug it into the original equation, see what that equals, and then check it with A and E. And hopefully that second number would eliminate one of them. A lot of times if there's a x squared or absolute value and one number works with more than one of the answer choices, then you might want to try a number further away from 0. Or if you tried a positive number, now try a negative number. Try a negative number further away from 0 than the positive number was. Like if you tried x equal 5 and A and B both remain, C, D, and E you eliminated. Well, then try x equals minus 10. It's negative and it's further away from 0. The absolute value is further away from 0 than the positive number you tried was. But that will come with practice. So again, two ways to do this, either by just adding the fractions as they are or plugging in a number for x.